Hello, this is question 6 from paper 2 from the 2020 Leaving Cert higher level maths exam. Up the top right of the screen you'll find a card that will bring you to the playlist that has all my solutions to the questions in this paper. And in the description below the video you'll find a link to an image of this question, so you can try it in your own time before looking at this solution of mine. Okay, question 6 is statistics and probability question. Two parts, there's a part A and a B that's unrelated to each other. Part A, it's a lot to read. I recommend you do it. Pause the video, read through it carefully. But it talks about a car park with cars in. We don't know how many cars. And then it breaks it up into 30% of the cars are diesel, 60% are petrol, and 10% are hybrid or electric. And that adds up to 100%. That's good. And then of each of those categories, it breaks it up into whether it's Volkswagen or not Volkswagen. Well, it just says whether it's Volkswagen. So the question then is just find the probability that if we pick a car at random, it's a Volkswagen. There's a couple of ways to do this. There's a couple of ways to think about these sort of questions. I'm going to show you two of them now. First of all, how I first thought of this is, I said, how am I going to write some of this information down? And the way I decided was I wrote diesel, petrol, and hybrid. And we just put in a few categories here. This probably isn't the best way, it's just the way I thought of. And I thought to myself, well actually maybe this is how I should say this. If you can, put real numbers down, okay? Probability and percentages are, some students find hard. If you can put down a real number and just add them all up, that's so much easier. It's not always possible. In this question it is. It's a simple enough situation. You can have a diesel hybrid, you can have a diesel your Volkswagen is diesel or it's not a Volkswagen. So we can actually add up all these so well, except we don't know how many cars. So if we just make up a number for how many cars are in this car park, it could be 10, it could be 100, a million, we can use that. Except if we pick a number too small, it'll be lots of percentages. So because there's a round number of a percentage, I know 100's a good number, but we use percentages twice here. We have a percentage of cars that are diesel, petrol, hybrid, and then inside that percentage that are Volkswagen or not Volkswagen. So 10,000 is a good number. 100 multiplied by 100. Don't worry if you didn't follow that. I'll have a different way to do it near the end. But I'm just going to decide there's 10,000 cars in this car park. And remember, 30% of them are diesel. So that means there's 3,000 diesel cars. Pardon me. 60% are petrol, so that means there's 6,000 petrol cars. And 10% are hybrid or electric, that means there's 1,000 of these. And then, I don't think I needed a table really at all. And then they tell me 70% of the diesel cars are Volkswagen. So what is 70% of 3,000? Get your calculator, it should come out, I believe, 2,100. And these are let's see, Volkswagen. I don't know why I keep forgetting the word Volkswagen. VW, and maybe we'll write not VW, just so makes sense me having a table. So not VW would be 900. So most diesel cars are Volkswagen. Petrol cars, 25%. We can get that by dividing by 4. That's 1,500. Our Volkswagen, and the rest, again, I don't think we need this number, 4,500. Hybrids, 9% of these are Volkswagen. 9% of 1,000 is 90. That means 910 of them are not. Okay, so now this is every single car in existence here. Remember, I made up 10,000. If we add all these numbers up, there's 10,000 cars here. So they're simply asking us, if we pick a car at random from the whole car park, what's the chances that it's a Volkswagen car? Well, how many Volkswagen cars are there? There's 2,100, another 1,500, and another 90. So the total Volkswagen cars would be, well, let's just write that out. 1,500 plus 90, and divide that by the total number of cars. And that'll give us our percentage. So this would equal, let's see, 3,690. 3,690 divided by 10,000. Get that to the smallest fraction, we would have 369 divided by 1,000. Or you could write that as 0.369. That's the probability of getting, either of these numbers are fine by the way, a fraction or this, and that's the probability of picking a Volkswagen car at random. Alright, now you didn't need to do this. You could have made up different numbers. We could have, well, let me show you what you could do in a moment. In fact, the probability itself is really assuming there's only one car. And we have 0.3 of a car here. We have 0.7 well actually, before I get into that, let me say how else we could have done this. We could have thought, what's the probability, how many Volkswagen cars are? There is 30% of the cars are diesel, so 0.3, and of them 70% are Volkswagen. So that's how many diesel Volkswagens there are out of one at least. That's the probability of getting a diesel Volkswagen. We're happy to get that. If we want to find out the probability of getting a Volkswagen car, a diesel Volkswagen's fine. Plus then there's the probability of getting a petrol Volkswagen. 60% of cars are petrol, and 25% of them are Volkswagen. That's the probability of getting a Volkswagen petrol. And then a Volkswagen hybrid, there is 10% of cars are hybrid, and of them 9% are Volkswagen. If we add this up, put this into, so this is all you had to do actually in this question. If you add this all up, you will get 0.369. That's the answer to this question. In a way, this is the same thing we did here. I did a 0.3 multiplied by 0.7. Here I did 3,000 multiplied by 0.7, I guess. I just multiplied everything by 10,000 really, is the big difference here. And at the end, I divided everything by 10,000. Okay, hopefully that explains something of this question, gives you a few ideas to think about. Put them in the comments below and ask me to clarify, because I know I probably wasn't that clear there. Alright, well, I'll rub this out and we'll move on to part B. Part B of this question gives a different scenario. It says the Road Safety Authority has data on driving tests. And part 1 is a slightly different scenario than part 2. So part 1, a driving centre, people taking a test have a 1 in 4 pass rate if it's their first time, I believe. Let's see, yes. At a centre, on a particular day, Joe, we have a person here, Joe, along with 5 other people, take the test. All 6 are taking it for the first time. So they each have 1 in 4 chance of passing, by the sounds of it. Find the probability that Joe passes the test along with exactly 2 more people. Alright, so we have 6 people in total here taking a test. Everybody's a first timer, so that means everyone will pass 1/4 and they will fail 3/4 of the time. What are the chances, Joe and exactly 2 others? Well, the chances of Joe passing are 1 in 4. And then we have 5 other people's chances here to do. Let me do it like this. The chances of the next person passing would be 1 in 4. The next person passing, 1 in 4. And then the rest of the people failing would look like this. And this would satisfy what they want, really. Joe here would pass, and exactly 2 out of 3 of them would pass. So the probability of exactly this happening, let's imagine these are A, B, and C. These are all real people. D and E, sorry, 5 people here. So the chances, this would be sort of, it wouldn't answer the question, but this would be the scenario they're talking about. Joe passes, let's put J in for Joe. Joe passes, A and B pass, and the rest fail. Now the problem is, this isn't the only way this could work. We could also have A fail and C pass. That's another possibility. We could have, in fact, here's all the possibilities. Joe will leave him as passing, but A and B in this scenario could pass. But also A and C could pass, A and D could pass, A and E could pass, also B and C could be the only ones passing, or B and D could be the only one passing. You could add all these up, all these things. Well, let's continue actually, because we're not too far from the end. B and E, C and D, and C and E. Oh, that's okay. C and E, and then D and E. These are all the different ways people can pass. Let's add these up. We've got 4, 7, 10 different ways. And from that, we can actually get the answer. Because this can happen this way, or it could happen this way. So we add those numbers together, this plus the same number again, plus this one again, plus this again, and they all have the same probability. Because if you rub out, so there should be 10 of these. So Joe has to pass, and then what about, let's pick out CE here. We would have a fail, we'd have a pass, C and E, a fail, and a pass. These are the same numbers as this. If we multiply this out, it will give us the same answer as this one here. So we just add all these together. We work it out for this case, Joe and A and B pass, Joe and A and C pass, or maybe it's Joe and B and D pass. We work out the probability of one of them and multiply it by 10. 10 total ways. So let's see, let's work this out. Plus, dot, dot, dot. So the final answer would be 10 multiplied by, let's see, how many 4s are here? That is 5 4s, so 4 to the power of 5. Top row would be 3 times 3 times 3, which is 27. We put that into a calculator, and I get 135 divided by 512. Or if you want that in a... I would leave it like that, by the way. They didn't ask for decimal places, so I leave them the exact answer. Say 3 decimal places might be good here. So 0.264 or 26.4%. That's the chances of the probability of Joe and exactly 2 other people passing. Now you might ask, do I have to do this every time? What if there was 100 people and I want to know if exactly 9 of them pass? The board's not big enough to do this. So there was another way to get this 10 number here. 10 was actually 5 choose 2. 5 choose 2 would give you 10. And it would give you any other number you wanted for this case. Alright, so that's it. If you know how to do this, you just write down this line, write down this number. It's not too bad. Right, the second part of this question, I'll rub out this bit here, and it should give me enough room. The second part is we're going to another test centre. In this other test centre, it's a 50% chance of passing, and it's a 50% chance of failing for everyone. So everyone has the same. And they say n people. So we're going into mathematics here. No numbers anymore. We'll have to use abstraction. N people take the test. Maybe that's 1 million. Maybe it's 5. We're not sure. Find the probability that 2 people or less pass the test. Oh, find that it can be written in the form they give here. Let's write out what they gave here. A n squared plus bn plus c divided by 2 to the power of n plus 1. Okay, so how do we do this? Well, in some ways it's similar, except we have 3 different questions it's asking. It's asking us exactly 2 people, just like here. It's asking us if exactly 1 person, or it's asking if exactly 0 people, because it's 3 different cases. 2 people or less is exactly 2, exactly 1, or exactly 0. So let's do exactly 2 first, because it's quite similar to this. N people do the test. So it's similar to these 5 people here, exactly 2 of these 5. So that's n, exactly 2 of them. N choose 2 is going to come out of this. And then let's see, of the people taking the test, we'll have a half, 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 and 2 of them will be fails. Well, they'll be half, half as well. So it'll just be a half n times. So this will be a half to the power of n. Let's put 2 here, for this is the 2 case. Now also, n choose 2, we can write that another way. It's in our formula book. I don't have my formula book, so I'll do this from memory. It's n factorial divided by or factorial n minus or factorial. I better double check this in the notes. If you're still seeing this, it means I was correct. Or is 2 in this case. So let me replace that with a 2 n minus 2. Alright. And we can actually do more here. Let's clean this up a little more. N factorial, sorry, is n multiplied by 1 less than n. So it's n multiplied by n minus 1 multiplied by n minus 2, n minus 3, and that stays going on. So n minus 2 factorial, I could say. This one stays going on. The bottom row has n minus 2 factorial. They cancel. And we're left with the n and the n minus 1. Oh, and a 2. 2 factorial is 2 times 1, so that's just 2. So we're left with that. The case that exactly one person does it. Again, there'll be n halves. There'll be, most of them will be passes, or in this case, they're mostly fails, I'm sorry. Most of them will be fails, which is a half. And there one person will be a pass, which is also a half. Still, it's a half to the power of n. This time it's n choose 1. That's a little easier to do. We can do the same thing if you want. But all we'll be left with is 1 factorial here. N minus 1. We'll just be left with an n. So n multiplied by a half to the power of n. I'm sorry, I left that out here. Did I? A half to the power of n. A half to the power of n. Okay, and then the case where 0 people... is this 0 people passing? What a terrible day. 0 people. Well, that'd be n choose 0, which is actually 1. There's one way to choose nobody out of n people. There's just one way to do it. A half to the power of n. Still, every single person failing would be, the probability would be a half multiplied by a half multiplied by a half. Says going. So that's just a half to the power of n. And there's 3 cases. We just add them together. What's the chances of this happening? Well, this could happen, or this could happen, or this could happen. We just add them together. So let's do that in a little box down here. We would get, let's see, n times n minus 1 over 2 times 1 over 2 to the power of n. That's what that is. 1 to the power of n is just 1. Plus, let's see, we would have another 1 to the power of 2 over n multiplied by an n on top, this one. And the last one would just be 1 over 2 to the power of n. Okay, all these bottom rows look very similar. 2 to the power of n, 2 to the power of n. 2 to the power of n multiplied by another 2. Let's rub that 2 out. That's just 2 to the power of n plus 1. To make all these bottom rows the same, I need an extra 2 everywhere. So we'll put an extra 2 on the top and bottom. So all these bottom rows now become 2 over 2 to the power of n plus 1. And the top rows, we have n squared here. We have 2n from here, and we have minus n comes from here. So 2n minus n is plus n. And what numbers do we get? No numbers, no numbers. 2, here we go, just 2. And that's the answer to the question, I believe. They wanted us to know, they wanted to know what A, B, and C was when it looks like this. A must be 1. Let's write that here. A equals 1. B must equal, let's see, B must equal 1. And C equals 2. That's the answer to that question. This is binomial coefficient, I believe it's called, as well. We have a formula to do this. It's pretty much what I wrote here. It's the choosing factor, n choose 2, n choose 1, whatever number. This is quite common. It comes up a lot in Leaving Cert. If exactly 2 or less, it means you'd have to do 3 cases. Exactly 1 or less, you'd have to do 2 of these cases. So it'd be n choose or, whichever those numbers are, then times the probability of one case to the power of n minus or, I guess, multiplied by the probability of the other case to the power of or. In this case, they're both a half. So it was a bit easier. It won't always look quite this easy. Alright, if you have any follow-up questions to that, please put them in the comments below. I'll do my best to answer. And thanks for watching. Have a great day.